Our final talk of the afternoon is from Caliph Wilson from Miltenyi Biotec. So I'd like to welcome Caliph now. He is going to discuss, waiting for Caliph to turn on his video. So Caliph is going to discuss CAR detection reagents and talk about how you can enhance the quality of identifying your CAR surface expression.
Hey, so hey, this is Caliph. You guys turned off the video, so it's gonna pop up. That's requesting that you turn it on. There we go.
Oh, there we go.
Hey.
Great. Sorry about that.
No worries. Hi, everybody. Let's get the talk up and going. All right. So thank you very much for, again, as everybody said before, can you guys see the talk?
We can't actually. Can you share your screen?
Oh, I was sharing. Okay. How about now?
There we go.
All right. Awesome.
Thanks.
All right. Well, we're always figuring out how to run this. All right, cool. Thank you very much for opportunity to speak to your audience. The talk title today is CAR Detection Reagents and Enhanced Quality of Identifying CAR Surface Expression. Now, as was said before, I'm Caliph Wilson, the field application scientist from Miltenyi Biotec. And so just as an introduction and give you guys a little bit of a breakdown, we're going to talk about what CARs are, how they're detected, and then scope of some of the applications that they're used for. So chimeric antigen receptor, or referred to as a CAR, is a artificially designed receptor. It's comprised of an antibody fragment that's connected to a hinge and the transmembrane domain. And then it recognizes, in this case, for our talk, we're going to talk about the recognition of tumor-associated antigens. And mainly these are going to be on cells that target cancers, like effector cells like T cells and NK cells. All right, so how are CARs detected? First, there are some antigen-independent labeling processes. So using like protein L or protein M. You can also have antibodies to the hinge regions of the molecule, which are somewhat constant. We also have antigen-based systems where the antibody portion or antibody fragment portion of the CAR binds to an epitope or full protein, and that protein is either directly labeled or labeled with a secondary. You can also have CAR-specific detection reagents, which bind to the antibody fragment, which are specifically for specific idiotypes. And some of the scoping and workflows that we look at and with CAR molecules are, whether it's human trials, or in this case, there's been some that have been improved human treatment, or mouse models. We're going to have our starting material and have various in-process controls. But primarily because CARs are either transduced in with lentivirus or mRNA, we're going to look at transduction or transfection efficiency. And then we're going to span some more and we'll look at the final product, and that product either is going to go into a person or a mouse. And in the context of a person, we're also going to have some immune monitoring downstream. And so our CAR detection reagents will be in our in-process controls, QC for the final product, as well as using it for immune monitoring to see persistence of CAR in human trials, or even in animal models to see if they're still there. Now, this slide is a little bit busy, so everybody don't focus on it and try to see every bit of information. The key thing we want to point out here is that from 2019 to 2020, even in the context of COVID, we still have a large increase of CAR-based cell therapies for people. And primarily, those therapies are either CD19, the B cell maturation antigen, or BCMA, or in CD20, CD22, CD123, and tumor-associated antigen CD33. And in this context, what we've done is selected out CD19 because it's obviously the most popular. If you have any CAR T cell experience or exposure, you've seen this a lot. BCMA, and CD22. And so let's jump right in and talk about Miltenyi solutions to detect CARs. And first, we're going to talk about the idiotype for the FMC63 idiotype antibody. And this is used in all of the CD19 CAR therapies that have been approved by the FDA. And we're also talking about different reagents for CD19, 22, and BCMA. So we talk about antigen-based systems to harken back to a couple slides ago. The antigen-based system can have broad applications in terms of you can target the same, you can use the same detection reagent to detect different CARs if you have a screening process. They're highly specific. They also mimic what the CAR sees in vivo, right? So the CAR is binding to a full length CD19, CD22, or BCMA molecule in vivo. And then in most cases, these are not directly conjugated to a fluorochrome. So you will have some secondary steps. So it's not a one-step process. And in the case of a lot of these, depending on which ones they are in context of ours, the shelf life is not as long as an antibody. So we have to consider that. And when we talk about the idiotypes, those are high specific, high sensitive, and the limitation is they're not specific. They're not good for CAR molecules that have different idiotypes. So if you mix up your clones, you will lose that ability to detect it. And then also there's some direct labeling, so you can shorten the time frame. But these reagents have great shelf life and great stability. So jumping right in and talk about some data. So what we're going to do is walk you through this data and help you understand why we consider our CAR detection reagents to be superior to other commercially available ones. So if we look at the Miltenyi CAR detection reagent, in this case, it's the CAR, the full-length fusion protein with CAR DR is biotinylated, and then we come back with our reaffinity anti-biotin antibody to secondary to stain for those. And so if we take a look at this, the MFI on this signal, and these are all the same cells that are stained with different reagents. The MFI is 80, stain index is 97. If we look at the first commercially available supplier, the percentages are roughly about the same. However, when we look at the MFI and stain index, it drops a lot compared to the Miltenyi product. And for supplier 2, we see that the MFI and the stain index drops even more. Now, if we take a look at some direct staining, or looking at staining for FC receptor, what we see is that in this particular CAR DR, it actually doesn't work that well. So it doesn't stain well. And then supplier number 3, their MFI and stain index is still a lot lower than the Miltenyi product. So in short, our product is giving you a more robust signal, a nice clear signal. And we're not only thinking about this in the context of just clinical trials, but also if you're screening, you need to have bright signal to discern whether or not your CAR molecule is there when you're trying to figure out which one to use. You also, in the context of your transductions, as well as doing immune monitoring, you need a very clear signal that can help you determine that your signal is there or not. We move into other types of reagents. So for instance, our idiotype for the FMC clone, what we see is directly conjugated to PE for hours versus a competitor. You can clearly see the nice separation and clear signal with the positive population. And we also have, when we compare this to our other reagent, we have 2 clones of this. We get nice bright signaling for both. And then when we look at our biotinylated molecule, the signaling is just as bright as the idiotype. And then there's another supplier, their MFI is a little bit lower. So in short, what we're just clearly showing and discussing here is that whether it's the idiotype antibody or the full-length protein or the fusion protein, we see a nice, brighter, clear signaling with our technology. All right, so those were CD19. Now let's talk about the BCMA. So if we take a look at the BCMA signaling and signal, and what we're looking at is our CAR detection reagent. So it's a full-length protein with the fusion FC portion from our recombinant antibody technology. Our MFI is 340 as measured here. And supplier 2, supplier 1, and supplier 3, they all give a percentage that are roughly around the same as ours, which is roughly 55%, but the MFI is a lot lower. So in certain contexts, this is going to be limiting to your applications. Now, an even more important characteristic is background. So I'm going to walk through this data set pretty slowly. So this data set is our negative control cells from lice whole blood that doesn't express the BCMA CAR. And so the data plot on the left shows that when you take a look at this data and you only add the biotin secondary, you have very low background. With our CAR detection reagent plus the biotin secondary, the background is very close to what the CAR negative cells are or without the CAR detection reagent. However, with some suppliers, if you add in their detection reagent plus the secondary, you see this background is very high. So this is all false positive. You don't have CD3 T cells that express the CAR molecule here in both of these upper right and lower left plots. Upper right and lower right plots, sorry. And there's another supplier doing the same thing. We're looking at their BCMA product, the BCMA detection product plus a secondary, and you still see there's an increase in background. Now, the danger in this is that when you're doing profiling, you're trying to understand what's going on with these, with your particular product or what's going on in the patient, false positive can lead you to believe that it's there. So there's a lot of things to consider when you're actually determining which CAR detection reagents to use, and background is a major portion, a major function of that. So the Miltenyi products give you a lower background, nice clean plots. And if you actually have a CAR positive CAR positive sample in here, you will see a nice separation and shift above background and can trust that data. So let's talk about comparisons of the comparisons using the staining process. So this is what the Miltenyi process looks like. We're gonna incubate 1 million cells in 98 microliters, add 2 microliters of our CAR detection reagents, incubate for 10 minutes, wash twice, add our antibiotic secondary, incubate for 10 minutes, wash, and analyze on our mass quantum cytometry. So for one of the suppliers, the key thing to point out here is that they have a lot more process. They have an hour incubation, they have reagent prep, and then a second incubation of 30 minutes. So this entire process is 2 hours, whereas the Miltenyi staining process is 1 hour. So the advantage to that is when you're thinking about handling cells and doing all the work, the longer the process takes, the more you're handling cells, whether it's RUO or clinical environment, that actually potentially leads to more mistakes and more error, and plus more time to actually get the work done. So to get ready to start closing out the Miltenyi solutions for CAR detection reagents, we have our full-length CAR detection reagents fused to the FC portion, and we also have antibiotin in a wide range of fluorochromes and pure. And for the anti-idiotype CAR detection reagent, we have it in several fluorochromes for one clone, and then the other clone, both clones are biotinylated or pure. And that's if you want to go into CyTOF or some other type of applications to do some more screening of your products. And also they are compatible with all your panels, et cetera. And I want to note too, we also have some dry products with the reagent in there. So with the panel already built. So if you're looking for something like that, that's going to simplify your work. And then the take-home message is simple. The CAR detection reagents are easy and quick handling. They're ready to use. They're sensitive and specific. they're made of recombinant antibodies and properties, so you don't have a lot of background. You can use these in RUO applications or clinical applications. And reagents can successfully migrate from the program. So if you start off only doing research work and you eventually move to the clinic, the reagents will follow you and you'll get consistent data and a stable product throughout that process. It's set up for flexible panel design, so you can move the CAR detection reagent across various dyes or parameters if you want to, and the protocols are faster. And also key, there's no need for FC blocking because of the recombinant technology. And thank you very much. And are there questions?
Thanks, that was a great talk, Caliph.